In today's video, I'll be showing you how to create this design. I'll be going over all of the steps in detail. Some of the cool things that we can do is change the overall rotation and overhang of this. We can also change the subdivisions. So if you're interested in learning more about parametric design and parametric modeling for architecture, this is a perfect tutorial. So with that being said, thank you very much for being here, and let's jump right into the tutorial. Alright, so to start, we're going to bring in a point. So let's go here to construct point. Then we'll route it through an empty point component. Now we can always change that point and change the location of the structure. So with this, we're now going to go to a move component and move this in the X direction. So I'll bring in unit X and bring in a slider. So now we have 2 points. Next, we're going to get the midpoint between those two by using average. So we'll use the first point and then hold down shift to add another point, and then we get the average between those 2 points. Now we can take this point and move it up in the Z direction. And use a different slider. So we can just copy this one to bring this up. Next, I'll bring in an arc component, but I'll be using the arc 3 points. So starting at the initial point, ending at this point that we moved in the X direction, and then going through the midpoint of the point that we moved up. So this lets us change and create an arc that's going to define the structure geometry. Next, we'll take this arc and then move it in the Y direction. So we can save that step by taking this move in the X direction, but this time we'll move it in the Y direction. So we'll replace the arc for the geometry and then bring in a Y vector and then decrease the spacing on it. Now, not only do we need to move the arc, but we're also going to move the point, the first point. So I'll take this, I'll tap Alt to create a copy, and then go back to the first point and plug that into the component here. So now we've moved the arc and we've also moved the point. What we're going to do now is create a rotation. So here at this point, we need to rotate this in relative to the YZ plane. So we'll create a YZ plane right at that point, and then bring in a rotate component using this plane as the reference plane, using this arc as the geometry. And now the angle here, we're going to go to degrees and then be able to rotate it by plugging in a slider for the degrees. So we have that at 45, but it's going in the opposite direction. So we can take this 45 and go to a negative component. This way it rotates 45 the other way. And then we can hide this arc. Now the other way to do it is to move this in the Y negative direction, and then the rotation would be in the correct way. But this also fixes that issue. So as you can see, what we've done is we've created this arc that it changes both of them at the same time. And we created the spacing between those two arcs. And now we're going to be creating a mirror plane. So what we can do is go back to this point that is up here at the top, and we're going to bring in a XZ plane and plug it into that point. Now to clean this up a little bit, I do sometimes hide the wire display. So on this one, so we don't have too many wires overlapping. So we'll take this and create, I usually reference here at the bottom left where it says XZ. So I'll go here to an XZ plane, and you can plug in a point for the origin. And now we're going to mirror this arc using this plane. So this mirror command is dependent on this arc, which means that if we change any of these from the initial one, it's going to happen in the opposite location as well. So now what we're going to do is create a loft. And this loft is going to be starting at this arc. We're actually starting at either one of these two. I'll start with this one. I'll flatten the input for the curve and plug in then the middle one. In holding down Shift, I can add another input. And then holding down Shift, I can add the last input. So we've created a surface between those three arcs, and the sliders that change it are going to be this rotation. We also have the spacing in between, and we have the height of the arc. Next, we're going to take this and we're going to subdivide it. So we'll take this loft and we'll use a Isotrim subdivision. What's cool about Isotrim is it comes in natively with Grasshopper, so you don't need any other plugins. And now here for domain, you do need to bring in divide domain squared. So the loft surface goes both into the surface input for Isotrim, also goes into the domain input, and then the segments goes into the domain input for the Isotrim here. Now we can use a slider for both the U and V to change the number of subdivisions that we want. So now we can change. We're going to need less subdivisions here in the Y direction. That's because we don't have as much surface area there. But when it comes down from this side to this side, we do want more subdivisions. Now the thing about Isotrim is that it does maintain the curve of the base surface. So to turn this into straight segments, we could take this Isotrim surface and go to Deconstruct Brep. And now if we take a look at one of these faces, so when you select Deconstruct Brep, you're going to see that it has all of them at once. So if we want to just pick one of them, we'll go to List Item. We'll be able to pick just one of them. But notice that these are all grafted, which means that it's selecting all of them at once. And they're all separated in groups, and it's selecting all of them. So if we flatten the input, we'll be able to pick just one of them. Now we can also do this by doing it initially to this Isotrim surface, just picking one of these, and then going to Deconstruct Brep to this surface. And notice that when you deconstruct it, you're going to get the faces, which is the surface, then the edges, which are these line segments, and then the vertices, which are the points that make up that surface. Now we can always change which one we pick. So if the index of 0 is this one, we can change it to index of 5, which is going to be 0, 1, 2, 3, 4, 5. And we can also do it to this one. What matters is that you pick one, because if we can do it to one, we could do it to all of them. So now that we picked one of them, we're going to go to vertices and go to polyline and plug in the vertices into the vertices input for the polyline. Notice that now we're getting these straight segments, but what we need to do is to create a closed polyline. So we'll go here to closed, set Boolean to true. And now with the polyline, we can go here to boundary surfaces. Or actually, we could just go here. So you can't create a surface with this one because it's not planar, but we could hide the surface here, hide this one. And if we go to Graft, so let's hide this one as well. And if we go to Graft, to this one, I'm going to do it to Graft on this one actually, because this is flattened. So if we graft this one, notice that we're getting straight sections for all of them here. Now, this may not be as structurally sound as using triangles. So what we'll do is go back to flattening this one. So if we can do it to this one, we could do it to all of them. And we're going to delete this polyline and bring back the Isotrim. Now we're going to connect 3 of these, but the way to know how they're organized, we can go to a point list. And here you're going to see what the numbers are. So we'll go here to size and change them because we can't really see it right now. 0, 1, 2, and 3. So we need to connect between 1, 0, 1, 2, and 3, and then create a triangle. So let's do that. So we have vertices. We have 0, 1, 2, and 3. So we have 4. So we'll go to list item, plug those vertices in, and then notice that it picks 0, just this one. But if we zoom in and we do the plus sign, we can get number 1, we can get 2, and then we can get 3. So let's plug in the first one, the second one, holding down shift, and then holding down shift, the second one, so 0, 1, and 2. And then we'll go to close, set Boolean to true, and turn this into a surface. Now we're going to pick, since we did 1, 0, 1, 2, and create a triangle, now we're going to go 0, 2, or 0, 3, and 2, and then close it. So let's do that. We'll copy this. We'll disconnect all. Now we'll start with 0, which is this one. Hold down shift, and then we'll do 2, 0, 1, 2, and then we'll do 3. Now notice that we're getting now this triangle, then this triangle. So all we did was take these vertices that create a square, subdivided them between the points that there are, and then created these triangulated polylines. And that's why we use this point list, because it shows us how they're organized and it lets us be able to use list item to create these triangles. So now we can take this and hide it because we don't necessarily need it. And like I said earlier, if we do it to 1, we could do it to all. So here we picked just this one item. Now we can go here to Graft. Now it's going to create a triangulation for all of them. So let's hide everything here. And now we have these two sets of triangles. And now we can join those together using ViewUpJoin. We'll flatten the input so it looks at everything as one long list, and we can hide this input. Let's also go back and hide the arcs because they're kind of getting in the way of the geometry. So all of this here at the beginning, we can hide. And now we're going to use ViewWrapEdges to extract all of the line segments. And the reason why we joined it is so we don't have overlapping geometry between these two panels. This panel has an edge, this panel has an edge, and they would be overlapping unless we join them together and extract both the interior curves and the exterior, which are the naked and interior ones. So here, let's go to a pipe component. Use the naked curves as the input, caps, round, and the radius will do 2.50. Now we can copy this and create a different thickness to the ones on the inside. So we'll go to 1.5. So what's cool about this is that when you create a triangulation, it's easier to develop, and it also makes it a lot stronger. And what's cool about using parametric tools like this is that we can always come back here and change the design by changing some of the inputs. So this is that rotation. Let's change the height. And we can also change the subdivisions here. So if 10, so we have 10 in this direction, and let's go to 5 in this direction. Now, lastly, I do like to organize this by, well, you can always keep the surface here. So we'll go to a geometry component that's empty, plug it into here, group it, and call this surface or triangulated surface. Then we'll copy this over here, and we'll go to group this and call this exterior or boundary structure 1, and we'll call this structure 2. Then we can hide this. And lastly, to kind of finalize this, we can go to custom preview, a color swatch to see what it looks like when we add materials. And then I will go to display for the wire to be hidden. And we'll go to the outside edge. I'll make this in grayscale a dark color, so 15. And then copy this down. Plug this one in. Maybe use this one as 25. And then for the surface, we'll change this to a blue. So let's go to something like 190. And then set the transparency to be 50. Now we can hide this triangulated surface so it doesn't overlap with the custom preview, and same with these two. Now these are straight sections that overall create the geometry that we had below. So it makes it a lot easier for you to be able to take these, cut them, and be able to put this together. Now the connections is a different story. I have other videos where I go over different connection types, but this is overall going over how to create the shape, showing you different tricks on how to achieve that. So hopefully you found that useful. But for now, let's go back to the beginning. We can organize this. We'll go here to set 1 point. We'll call this structure span. And call this the structure height. Also try to organize this a little bit. I don't like wires to overlap, so that's something else I keep in mind here. This is going to be structure depth. This is going to be rotation angle. This will be U and V subdivisions. And I group it, and I have the color set as green here, and you can set whatever color you want as your default. So just select whatever color and go to make color default. And I do that so I can know which sliders to change here. Now this one, it's not that critical because whatever you do to one, it'll do to all of them. So this one, I can even just go here to 0. And it's not going to make a difference here. Let's see, this one is not critical. So on this one where we only need to do this one, I do like go to internalize data. This way it puts 0 inside of here, and I can just delete this. And this is just so you can see how the points are organized. So I will leave this one here. Point list, but I won't highlight it because that's not one that I need to change. And then here we'll go to structure 1 and structure 2. Let's see, there's something that's just not nice here. All right, so that concludes the tutorial. Thank you very much for watching. Hopefully you learned something new here. A lot of the tricks here that you saw in this tutorial can be used for so many different designs. I'm just making sure that I show you all of the steps in detail here. So thank you very much for being here, and I hope to see you in the next video.